Hello, everyone, and welcome to our webinar today. In today's session, we will discuss the Fronius GEN24 hybrid inverters. And joining me today is my colleague, Cyprian Okolo. He is the technical sales advisor for the Western African region, and myself, David Mwangi, the technical sales advisor for the Eastern African region. So our agenda for today, we will look at the different inverter variants for the GEN24 Plus family. We will look into the GEN24 Plus wiring, then the data communication. We will also talk about initial commissioning of the inverters, then the GEN24 Plus compatibility. We will also look at the storage solutions, applications, and afterwards, we will provide you with further information. So before we get started, please feel free as usual to post any questions that you might have during the course of the webinar in the questions area. And then after the webinar, you can give us feedback as to whether you enjoyed the content and your general opinion about the particular webinar for today. So let's get started and look at this GEN24 Plus inverters. So the GEN24 Plus inverters are uniquely versatile. They offer you the option for emergency power. They are designed to maximize self-consumption and self-sufficiency out of the PV systems installed. And in addition to that, the design of the GEN24 also allows for easy installation and commissioning. We have two variations of these inverters. We have the Primo series and the Simo series. So the Primo is a single phase inverter that is available with 2 MPPTs and 1 battery input. The power class from 3.0 to 6.0 kilowatt. We have the Simo GEN24. This is a 3-phase hybrid inverter and comes with 2 MPPTs as well and 1 battery input. The power class available for this inverter is from 3 kilowatts up to 10 kilowatts. Looking at further details about the variations or the variants, we have the Primo GEN24 Plus, which is the single phase inverter, hybrid inverter. So the power classes for this inverter start from 3 kilowatts, then 3.6, 4, 5, and 6 kilowatts. So it comes in a comparatively smaller housing when you look at in comparison with the Simo GEN24 Plus. In terms of the MPPTs, we have the current handling capacity of 22 amps and 12 amps for the 2 MPPTs. So you can see here, one of the MPPTs has a higher rating than the battery input is at 22 amps. So this therefore means that with this Primo GEN24 Plus, you get the PV point, which is the optional power or opportunity power, plus the full backup when you have a battery storage integrated. We also have another variant within the Simo GEN24 Plus. So this is the smaller power class of the Simo series, which is 3 to 5 kilowatts. So this is available in 3, 4, and 5 kilowatts. It comes also in a smaller housing comparatively. With regards to the MPPTs, here we have the current handling capacity of 12.5 amps for each MPPT, and the battery input can also take a maximum of 12 amps for discharging as well as charging. So because of this, then the smaller variant of the Simo GEN24 Plus is not able to give you full backup, but you still are able to get the PV point, which is the opportunity power that can be used or obtained from the GEN24 without a battery storage. With a bigger GEN24 Plus, this is the power class 6, 8, and 10 kilowatts. So this comes in a bigger housing. For the 2 MPPTs, we have 25 amps and 12 amps. So we can see here, similar to the Primo GEN24, the bigger SIMO GEN24 has a higher current handling capacity for MPPT1 compared to MPPT number 2. And then for the battery input, we have maximum current of 22 amps. And therefore, this means that the SIMO GEN24 6, 8, and 10 kilowatts can provide you with both the PV point and full backup. So this full backup is only possible with a battery connection. So the characteristic of the GEN24 is quite similar as far as cooling technology is concerned, compared to the snap inverters that a lot of our partners and installers are familiar with. So we have active cooling integrated in the GEN24 Plus. So you can see that the cooling fan is centrally placed. So this allows the inverter to suck cooling air from the front side of the inverter. And then you have consistent heat removal throughout the sides of the inverter. So you can see the design of the heatsink allows the hot air to come out of the inverter from all directions. So this means that the cooling technology of the GEN24 is a lot more efficient than even for the snap inverters in this sense. So because of this, also side-to-side mounting of GEN24s, or if you are AC coupling GEN24 to an existing installation is possible, but the ventilations on the side, as you can see them, have to remain unobstructed. So the special attribute also about the heatsink of the GEN24 Plus inverters is the fact that this heatsink is made out of recycled aluminium, and therefore the implication as far as the impact for carbon dioxide during the production process is that with a new aluminium heatsink, you have possibly up to 100 kilowatts of CO2 that can be emitted in the process. But with the recycled process, is just about half of that will be required. So in this regard, you can see that the GEN24 is actually more environmentally friendly because it's using the heatsink from recycled aluminium. So what are therefore the advantages of the active cooling technology? So one of the key advantages is that the inverter is able to operate in much higher ambient temperatures, and therefore, as we know, the derating of the inverter is dependent on the temperature as well as the DC string voltage, and therefore, when the inverter is actively cooled, you keep the electronics inside the inverter within a favorable working temperature range, and therefore the derating happens at much higher ambient temperatures. However, if the heatsink temperature goes to about 75 to 80 degrees Celsius, then the inverter output will be derated, and the state code related to heat will be sent to SolarWeb. But then again, if the temperature continues to rise above these 80 degrees, then the inverter will shut down and a state code will likewise be sent. So here we can see an example of an operating graph relating to the nominal power rating of the inverter, which is in this example a GEN24 Plus 8.0 kilowatt, and the ambient temperature. And we can see here that the inverter is able to give you full output even up to about 50 degrees ambient temperature. So let's now talk about the wiring of the GEN24 Plus inverters. So the other special attribute of the GEN24 Plus inverters is the fact that these inverters come with 180 degrees quick locking screws, and therefore this means that to tighten or to unscrew the screws from the inverter, you do not need to go the full motion like we are used to the snap inverters. So this will only be done by making 180 degrees turn to the left or to the right, depending on whether you want to tighten or loosen the screw. And we can see that the front cover is secured by 2 screws. So once you release these 2 screws, then you have access to the DATCOM cover, and the DATCOM cover is held in position by these 5 screws, which are also quick release screws. We also have a DC switch that needs to be in the off position. So we can see this switch here is the DC switch. So this one needs to be in the off position for you to be able to remove this front cover. As far as the tools are concerned, we recommend the use of only a Torx screwdriver TX20. So therefore, we do not allow the use of a cordless screwdriver, or a metric screwdriver for working on the GEN24 Plus. So once you take out the DATCOM cover, then you are able to access the connection area. And this is an example of a SIMO GEN24. So you can see we have the connection area for DC on the left and AC power to the right side. So for AC power, we have the normal connection, so phase 1, 2, and 3. And then we also have another separate connection for the PV point. And we have another additional connection, which is the grounding terminal block, that can be used to extend. Maybe if you want to connect to another node directly from the inverter, then you can connect to this one here. And then in the middle, we have the pilot, which is the data communication unit or module of the GEN24 Plus. And we also have the separator that keeps the data communication area separate from the DC connection area as well as the AC connection area. For the DC connection area, we have a shared connection between the PV and the batteries. So in this case, we can see that, for instance, we do have the connection here for PV1. We have 2 strings and 1 string on the positive connection from the PV array, and then the positive connection for the battery. And then on the second connection for DC, we have the negative connection, whereby we have the battery, PV2, and then 2 strings for PV1. So, and yeah, so that's as far as the connections are concerned. Then if we go further, we look at the specifics about the connections and how these are achieved. So for the DC connections, we have 10 connections points. So these are the special cable glads. As this is position number 10, as we can see in this illustration. And then we have the separation from the connection. So this is internally of the inverter. We also have the optional cable glads for grounding and backup power gland that can be done on position number 11. So this would be on the bottom side of the inverter, as you can see the real picture here. And then for position 12, we have the optional cable glad for Wi-Fi antenna as well as data communication. And then position 2 and 3 within the inverter, which are actually directly on the pilot card. These are for data communication. And then you have the cable glad for data communication, which is position number 8 here, and the cable glad for the AC area connection, which is number 6 here, which comes provided, as you can see. So this is the one for data communication, and then the one to the right here is for the AC connection. So as far as the separation area is concerned, so this allows the separation of the DC and AC cables, as I had mentioned before. So they are kept separate from the data communication area. So, and the separator itself can actually be removed when you're doing your installation to make the work easier. And yeah, the fitting of the same is actually quite easy. So we can see here the various components that are related to the separator. So from the integrated cable glad, indentation for removal, then the unlocking via the snap hook, whereby the separator is secured in the inverter. And then we have position 4, which allows for a knock-off or a knockout for DATCOM communication cables. The grounding terminal block, as I had said before, is an additional adding connection for the inverter. But we can see here the functional grounding is actually within the AC connection area, so it can be fitted with a maximum cable of 10 millimeters square. So the terminal block, the additional terminal block for grounding can be things for like for add rods if you want to connect directly. And here you have the possibility to connect cables up to 16 millimeter square. So this is just an additional. And for when you connect the PV point, actually, you also need to connect the neutral part of the PV point connection area to this terminal block for earthing. So that we have some bonding there between the PV point and the earthing connection. When it comes to the DC disconnect, we have 3 positions for this DC disconnect. So we have the lock position, we have the off position, and the on position. So when the DC disconnect is in the on position, and therefore we are talking about the position 3, and you have it locked in position 1, then you're able to protect the inverter from switching on or off, depending on which position you want the DC switch to be left at. And therefore, for that purpose, a padlock can also be integrated into that scenario to allow you to secure the inverter in a certain DC switch position that you desire. So this DC switch also mechanically locks the front cover of the inverter, as I had mentioned before, so that when it's in the on position, you are not able to take out the front cover until you put it in the off position. For the AC and DC connection area, we have provided the cable gluts, and for the AC area, we have M32 cable glut, which can be tightened by about 6 to 7 Newton meters. And then the DC area, you have the cable feed throughs that needs to be where you put through the cables, as we can see here. So you do not require to take the DC connection area out for you to fit the cables through. And then you also do not allow the use of knives for making perforations for connection of the cables. So you can insert the cable directly into it, and then that ensures that there is enough closing of the cable glut around the DC cable. And then for the 2 screws at the top here, we are going to allow only 1.3 to 1.5 Newton meter for tightening that strain relief for DC cabling. Another very special aspect of the GEN24 Plus inverters is the fact that it comes with a push-in spring clamps, and these are actually removable when you're doing the installation. So you can see from the back of the clamp, there is a locking and unlocking mechanism that you can press to release. And then this allows very fast fitting of the cables, because you just lift the clamps on top, and then you insert the cable and you lock the clamps. So once you get a click, then it means that the clamps have secured the cables. And then in terms of the cables, you do not require to use ferrules, and the maximum cable cross section that can be used for the GEN24 Plus is 10 millimeter square. So when it comes to the data communication, we have the provided cable glut here. So when you want to fit in the datacom cables, it could be an internet connection to a router if you're not able to use the Wi-Fi connection. Then you need to remove only the knockoffs that are going to be used. So as you can see in these illustrations, you should not remove all the knockoffs from these cable gluts, because then that would expose the inverter to dust or other kinds of ingress things that could affect the connection area. And therefore, take out only the knockoffs that are going to be required for the number of cables that should be used. Once you do that, it's required that then the seal ring, which is this particular part, is put in the opening between the cap and the opening of the housing, and then you press it in until the strain relief is released. So here, the strain relief is from 2.5 to 4 Newton meters as far as tightening of this cable glut is concerned. In terms of the data of the cables in general for data communication, as well as DC and AC power for the Primo and Gen and the SIMO GEN24 Plus. For the connection area for AC and DC, we require copper cables, and this is for both the AC PV point as well as DC. And in case of integrated SPDs, then the cable cross section that can be used is affected slightly, so this needs to be reduced slightly. And then for the grounding terminal block, as I had said before, you can connect here a maximum of 16 millimeter cable cross section. For data communication as well, we do require copper cables only. We have the WSD, which is the wired shutdown. This can run a maximum of 100 meters. We have the Modbus connection, which is used for the smart meter connection. This can be run for a distance of a maximum 300 meters. And then you have the IOs, which are the inputs, output from the inverter. They can go a distance of maximum 30 meters. So for all these three connections, we do require maximum 1.5 millimeter square cable cross section, which must be copper. And then there is also the possibility to use the LAN Cat5 shielded twisted pair cable, which can be run for a maximum of 300 meters. And this is specifically for the Modbus connection, for instance, for the smart meter. The GEN24 Plus is coming also with some options on the DC side, and these are related to OVPs or the surge arresters. Here you can get the type 1+2, but this is only available as a retrofit kit. So this is not installed as a standard component when the inverter is being produced. So here we can see how the SPD is fitted and how therefore the cross section of the cables would be affected on the DC side. So once you fit the SPDs here, you can see there will be some restriction here on the maximum size of the cable that can be used on the DC side. And this would be ordered normally through your wholesalers or your sales, the Fronius distributor. And yeah, it would be provided as a print as it is here with 4 screws, a grounding cable, a 2-pole signaling cable, as well as PV plus and PV minus for connection to the DC area. As you can see, the connection on both sides of the DC connection area. If you want to be sure that you have designed the right kind of string connection for either the SIMO GEN24 or the Primo GEN24, then you can make use of the Fronius design tools. So we have the Fronius Solar Creator, and within the Solar Creator, we have a quick design function that allows you to verify the string configuration that you want to use for any particular inverter. But as far as the DC input range is concerned, for the SIMO GEN24 Plus, this would start from 80 volts to a maximum of 1000 volts, which means that you can start from 3 modules to a maximum of 24 modules per string. And then in terms of the over dimensioning, this can be done to a factor of about 150%. So, but the maximum input currents, these are important to note for the SIMO GEN24, 6 to 10 kilowatts. We say that we have maximum 25 amps on the first MPPT and 12.5 amps on the second MPPT. For the smaller GEN24 Plus, SIMO GEN24, we said we have 12.5 for both MPPTs, and therefore that difference is important to consider. For the Primo GEN24 Plus, the voltage range is 65 volts to a maximum here of 600 volts. So we can see here also we have quite a big difference between the SIMO and the Primo GEN24 Plus. And therefore it means for the module configuration, we can start from a string of 3 modules to a maximum of 14 modules per string. But the over dimensioning can be achieved also to a factor of 150%. So for connection to the PV side, the SIMO Gen and the Primo GEN24 inverters, similar to the SNAP inverters, come with the SuperFlex design capability. And therefore, here we can see the possibility to connect, just like we have said, strings starting from 3 modules. And the DC start voltage is about 80 volts. So therefore, you can either connect the strings directly, depending on the design, or you can do a split connection, as you're going to see later. As far as the safety devices that are integrated, we have the isolation measurement that is done every before DC power is put on, before generation in the morning. We have the RCMU for monitoring the residual currents during feeding process. And then you have the grid fault detection, or the anti-idling, that allows the inverter to switch off immediately if there is a grid disconnection. So when you have a grid disconnection and you have a battery connection, it is important to also wire the GEN24 up for full backup functionality, so that when the anti-idling is activated, then the inverter with the full backup wiring can be enabled to use battery storage to continue powering your loads. We also have reverse polarity protection. This is done through diodes. We have also over voltage protection as an option. So we have said these are available as retrofit kits. And then we have the power reduction, depending on the temperature of the inverter. Then the inverter is able to reduce the power output to prevent damage to the electronics inside. We also have another component or accessory that can be used with the GEN24 Plus inverters, and this is the DC connector kit. So this is especially for when you're using the high power modules. As we said, there is a max current that can be connected to the MPPTs of the GEN24, which is 22 and 25 respectively for the Primo and Simo GEN24. So you could also use this DC connector kit with a smaller SIMOs 3 to 5, but because of the currents of about 12.5 per tracker, this might not be required for the smaller SIMO inverters. When it comes to the connection itself, when you design a string which generates more than 25 amps, maybe you want to pre-combine these strings, but still want to do a connection to a GEN24 Plus inverter, then we recommend to do a connection using the DC connector kit, so that instead of now going directly to the inverter from the modules, then you connect, as you can see here, for the same GEN24 with a DC connector kit that would allow something that is equal or slightly less than 60 amps to be connected now between the two MPPTs. And for the Primo GEN24, then the DC connector kit would allow something in the range of 22 amps to a maximum of 55 amps to be connected to the two MPPTs within the Primo GEN24. The technical parameters of the DC connector kit, it can operate at a maximum voltage of 1000 volts. For the short circuit currents, the Simo and Primo GEN24 Plus, the DC connector kit then would be able to handle 56.26 and 51 amps correspondingly, and then the cable cross-section area starting from 4 millimeter square and maximum 16 millimeter square. And the cable type, it's very important here also to underscore that it's only copper cables that are allowed for connection to the DC connector kit, and this can be either the stranded or the single core kind of cables. So at this point, I would like to hand over to Cyprian, who will do the remaining part of the webinar. So Cyprian.
Yes, indeed. Thanks a lot, David, for a wonderful presentation. I will be continuing from this point to take us through the data communication, installation and commissioning, storage solution, and its different applications. Great. So let's continue. So in terms of data communication, it is obviously essential to ensure that there is a means by which our inverter can be communicated with. As you can see in this case, that the GEN24 Plus and of course the Tauro don't have a display unit, just like the Snap inverters do. So the display interface will basically be our monitoring or commissioning devices, which will basically be our smartphones or tablets and laptops. So this now behoves that there should be a communication device that will be used to communicate seamlessly with the GEN24 Plus inverter. So what is basically needed is, of course, your commissioning device, which is basically going to be a smartphone. And then, of course, you'd have to download the commissioning app, which is the Solar Start app. So once this is done, you can be able to do the commissioning by communicating with the communication device or medium, of course, via internet availability, via router. And then with this, you can be able to monitor your system from anywhere you are in the world, either by with your smartphone, your tablet, or your laptop. Of course, you'd ensure that your device are all web-enabled devices. And then this startup app is available, freely downloadable on Apple, iOS, Android, and then Windows devices. Good. So talking about this communication device, it's none other than the Fronius GEN24 Plus, the pilot. So basically the pilot is the communication medium that is used to communicate with the GEN24 Plus inverter. Embedded or integrated in this pilot are LED status display, data logger, web server, and it also serves as the Wi-Fi card. And with this, we will be able to gain visualization via Fronius Solar Web portal, of course, the Fronius Solar Web app, and then, of course, the Solar TV. Integrated also in this pilot are multiple open interfaces, which include 2 Ethernet or LAN ports, usually called Modbus TCP, which is also used for Fronius Solar communication using the API or JSON protocol. We have 2 Modbus RTU interfaces in comparison to the data manager that has 1. So this has 2 interfaces, Modbus RTU interfaces using the RS485 communication protocol. And then we have a peculiar feature, which is the wired shutdown function. This will be discussed subsequently in the coming slides. And then, of course, we also have the digital input-output ports that can be used to implement energy management protocol or processes. So let's just have an overview, a brief overview of the integrated interfaces. So as you can see in this case, and as mentioned earlier, let's start off with the Modbus RTU, as can be seen here. So this has 2 Modbus RTU terminals, which are represented by Modbus 0 and Modbus 1, as you can see in this case. So these switches are all integrated around this position, just to the front position of the pilot. Beside them is the wired shutdown terminal or terminal switch. And then this is the terminal itself. So this is the switch, and then this is the terminal itself. And then we have the input-output ports, as can be seen here. And then next to the Modbus switch is the LED button, and then beside it is also the LED sensor. Slightly beneath the sensor are the LAN ports. We have LAN 1 and LAN 2. I'll be telling us more about them and their respective uses. And then slightly towards the bottom left of the WSD is what used to be, I would say used to be because it's no longer available in subsequent pilots that have been manufactured after Q2 of 2022. So this is usually meant for power supply, but then we have multiple power supply terminals that we can get our DCs from, which is from the input-output ports, as you can see in this case, and also from the Modbus RTU terminal. So this USB port is no longer available with subsequent versions of the pilot from Q2 of 2022. Good. So going forward, let's now have a look at the Modbus interfaces bit by bit. So for the Modbus RTU, communication is via RS485. This comes as a pushing clamp, as you can see, the orange plug. And then it has two Modbus interfaces that implement the RS485 communication protocol. We have the switches, their respective switches, as you can see in this case. Let me just zoom in a bit. So you can see the switches. So this is Modbus 0, and then this is Modbus 1. So ensure for communication purposes, the switches are supposed to be in position 1, that is switched towards the right-hand side. So, and then if properly implemented, they can be used for communication with the Fronius smart meter, the home pilot, and of course, for SunSpec interface purposes. And then an additional information about this switch is that putting it on position 1 actually turns on the internal and integrated 120 ohms resistor. Basically, for communication to take place, there has to be a closed loop between the receiver and the transmitter. So these 120 ohms resistor serves as the loop terminal. That is basically the loop closers, per se, the components that closes this loop for efficient communication. So there has to be this 120 ohms at the end of the communicating devices. So for example, if we're communicating with a smart meter, so we should enable the 120 ohms terminal resistor on the pilot here, and then also on the smart meter in this instance. So, and must mention here that although not fully covered, smart meters, modern or new smart meters that are being manufactured by Fronius now comes with integrated 120 ohms terminal resistances that would have to be actuated simply by looping one end to another with jumper cables. So we don't have to use a physical 120 ohms resistor to do so. Good. So having said so, turning it off basically turns off the terminal resistor. So in this position, there will be no communication. Good. Let's continue now to the wired shutdown interface, as earlier promised that I was going to talk more about it. So basically, the WSD, or otherwise called the wired shutdown, is a safety mechanism that has been implemented in the pilot to enable emergency shutdown, emergency system shutdown. So just to give us a quick instance of how this can come into play is in an event of fire outbreak on the roof, per se. Once this happens, of course, it poses a great risk, a great electrical risk, because we could have an eventual cause for short circuits, and then the inverters and systems or appliances connected could also be exposed to electrical failures. So, but with this wired shutdown, it makes it possible that by the push of the trigger switch, which is usually a normally closed button, you can automatically shut down the entire system, even if it is one inverter or more than one inverter. So this WSD switch basically interrupts the feeding process of the inverter if the trigger switch is activated, just as explained in the earlier instance I have given you. So the WSD has a master-slave position. So in the case where you have a multiple connection of inverters, so we will definitely implement a master-slave protocol, which will be explained in the coming slides. The recommended maximum distance between two devices is 100 meters. and then the maximum recommended amount of device to be connected is 10. Usually the WSD terminal plug is delivered in a bridged format, that is the in-to-in terminals. The in plus and in minus are bridged. So with this, it automatically shuts off the function of the WSD. Once it is active, the in plus and in minus will now have to be connected to the trigger switch, which is usually an emergency switch, as we will see in the next slide. So here is it. So this is basically what the emergency switch looks like. So it usually comes in a normally closed orientation. So once the switch is triggered, it now opens the circuit and shuts down the system. So it is usually called a fireman's switch because it becomes a fireman's best friend in, of course, making the electrical connections safe in the case of a fire outbreak. This is actually this application is already in practice and is a normative order in the US. And then we have other countries and regions that actually have this as a specific legislations for PV systems on public buildings. Good. So like I mentioned earlier, if you have multiple inverters, obviously multiple pilots to connect. So this is how the orientation should be. The device or the pilot that is connected to the trigger switch, the WSD switch should be on the 1 position, that is on the master position, whilst the others should be in the 0 position, as you can see. So basically the out terminal of the first goes into the in terminal of the next, and that is the way it continues until the last inverter is connected. Usable cables are Cat 5, 6, and 7. So like I've mentioned earlier, the master or the inverter connected to the trigger switch should be in the WSD switch should be in the 1 position. So in the case of failure of one slave, it will be recognized as a bridging fault. But in the case of a failure of the master device or 2 slaves, this would result in the triggering of the switch. Okay, so looking at the integrated, still looking at the integrated interfaces, we're now talking about the digital input-output ports. So for this, we have 4 dedicated input-output ports, which are in practice used as output ports. So these are our input-output ports 0, input-output ports 1, 2, and 3. So these 4 input-output ports are used basically as output ports. And then we have dedicated 6 dedicated digital input ports, which are input ports 6 to 11. Now, for these input-output ports that are eventually or in practice used as output ports, they are basically used for intelligently managing heavy loads like pool pump, air conditioners, charging of electric vehicles, heat pumps, and the likes. It can also be used for implementation of backup power and then demand response mode, which is usually implemented in Australia, if I'm not mistaken. Good. So going forward, let's now have a brief look on how to configure load management as mentioned in the previous slide. So this can be possible once we access the web user interface and then go to settings. From settings, we go to energy management, and then we click on load management. This seems a bit far, so let me bring it close a bit so that we have a closer view. So this is what it looks like. So you have the liberty to label what you want to implement with the load management regime. So for this is load management 1. So basically, for example, we might say, okay, we're using the input-output port 0 or 1 to implement this. So once we name it as we deem fit, in this case, it is labeled heat pump, we can now choose what conditions would necessitate the triggering of this heat pump. So it said that you could disable it, that is, if you don't want to implement it, or you could enable it by power production or by power surplus. By power production simply means so long as your PV is generating, then the heat pump will be turned on. So this usually is not pretty much economical per se, but then it depends on the priority of function. But then the method or the choice normally implemented is by power surplus. So this basically means that once your base load have been sufficiently supplied, and then you are now generating more than you are consuming, then you can now use the surplus power to trigger your heavy loads, in this case labeled heat pump. Next up is to now assign or configure the conditions of the triggering of this heat pump. So basically, we're going to assign the turning on and turning off conditions. So operating mode, in order to make it come on, is basically in the consumption mode. So this basically means that once your consumption is up to 1,000 watts, then the heat pump is automatically turned on. And then once the consumption is drops down to 500 watts, then your heat pump goes off. So with this, you're able to control the turning on and turning off of the heat pump with respect to the surplus energy generated. It is also possible to have it come on for a particular duration of time. So minimum is usually a minute, and then maximum is 60 minutes, so basically an hour. So one important thing is, once this settings has been made, please ensure that you click on save, so that this saves in the memory of the inverter and then implements this protocol for you. If not, nothing will happen. Okay. So going forward, still on the overview of integrated interfaces, we're now looking at the LAN ports. So we have two LAN ports, as earlier mentioned, but only LAN 1 is usable. LAN 2 is actually dedicated for internal use. And as already mentioned, for the non-integration of the USB, which has already been discussed. And then we also have the LED display, which are situated in these positions. So after discussing about all the features of the pilot, what next is to discuss how we can actually gain access to the inverter via its access point. So the inverter basically has a Wi-Fi access point that can be accessed. So how do we do this? First off, before we do that, we of course ensure that the inverter cabling has been properly done, checked, and certified, let's say. And then we'll mount the DATCOM cover, and then of course the inverter cover. So once this is done, we can now conveniently put the DC connector switch on position 1, thereby turning it on. That means now that we are ready to activate the Wi-Fi access point. So this is triggered by simply pressing on the touch-sensitive button right between the LEDs, the status LEDs, as you can see. So once this is done, by pressing the touch-sensitive button once, in approximately a second, you're going to open the Wi-Fi access point, which will be indicated by the blinking of the blue LED. So we're going to discuss more on that in the coming slides. So going forward to the installation and commissioning of the GEN24 Plus. So we now continue from where we stopped in terms of having access to the inverter. So there are various ways that we can actually communicate with the inverter using the touch button. So one quick push for approximately a second, as seen in the previous slide, automatically activates the Wi-Fi access point. Two quick pushes activates the WPS function. WPS here simply means Wi-Fi protected setup. So with this, it basically bypasses use of passwords. So once you can activate the WPS function, you can basically connect the inverter to the internet without the use of passwords. One long push for about 3 to 6 seconds deactivates the service, deactivates service messages. And then this also either activates or deactivates the key lock. So let's now talk about the LEDs. For the LEDs, we would notice that there are 2 LEDs flanking the touch-sensitive button. The left LED is called the operational LED, symbolized by the power icon, while the right LED is the communication LED, which is symbolized by the Wi-Fi icon. So what does the colors, the respective colors of this LED tells us? So if it is solid green, it means that the operation is okay. If it is on yellow or amber, it is on standby. If it is on flashing amber, it is a warning sign or warning signal. And then if it is a solid red, that means that you have an operational error. Talking about the communication LED, if it is solid blue, it means that you are online and properly connected. If it is flashing blue, then it means that the Wi-Fi access point is open, just like we saw in the previous 2 slides. And then if you have a red on the communication LED, it means that you have a communication error. Good. So let's now talk about how we can conveniently commission our inverter after having access via the Wi-Fi access point. So this is, of course, made possible by the use of the SolarStart app. This is only available on the mobile devices, not yet available for desktop. On the no desktop version available. And this can be done, the commissioning can actually be done in 3 easy steps that are actually user-friendly. So it basically entails the imputing of all the necessary information, including the network information that is bringing or connecting the inverter to the network or to the internet, and then imputing all the respective product particulars and configurations. And then afterwards, this is now followed up with the uploading of the system data, or basically registering it on our database, which is the SolarWeb. So, like I promised, we have integrated a short video that will describe the process of commissioning of an Gen24 inverter using the SolarStart app. I will basically play it and then do a brief voice over. So we can see how this is done. The DATCOM cover and the inverter cover are put in place, and then the disconnector, DC disconnector switch is put on position 1. The touch sensitive button is pressed approximately 1 second. You can now see that the communication LED is blinking. Next up, we download our SolarStart app and then start the installation process. Please ensure that you have your credentials that you can use in logging in. Even if you don't have a credential, it is also possible to do so using the guest version. But for this case, for this purpose, or for this example, we're using a particular login detail. So continuing, once you put in your login detail, you can now start the installation. Usually, before you just start your installation, there is usually a process by which you would have to download a particular firmware. If the firmware of the inverter you're about to commission is not up to date, you will receive an automatic prompt to download the most recent firmware. Once this is done, you can now continue with the commissioning. So you can use this app to commission either the GEN24 Plus, the Tauro, the Snap Inverter, the different types of Snap Inverters, and of course, other accessory devices like the data manager box, for example. So continuing with the video, you can now access the Wi-Fi access point. You'd have to impute for the network adaptation, you have to impute the customer password so that you can have access to it. So once that is done, you impute the system name and then the requisite terms and conditions are agreed. You can now go to the next point where you have to connect with the internet. In this example, they're using the WPS function. And then once you're able to connect with the internet, you can now see from the background, although I've stilled the image, but once I play it, you would see that the blue light that was blinking is now solid, as you can see in this case. So this signifies that the network connection has been done. You now go ahead to the product particulars section where you input all the necessary product particulars, right, device configuration, functions and IOs, export limitations, all the necessary data would be required to be entered. So once that is done, you can now go ahead and then add them up to the system. As you can see, if you want to implement load management, you can do so. If you want to implement export limitation, you can also do so. Then followed by the registering of the device to SolarWeb. And then once that is done, you can now finish your commissioning, and then you have that your system has been successfully added to SolarWeb, and your commissioning is done by, of course, seeing the checks on the 3 user-friendly process as earlier mentioned. So that's basically it. So just to round up, you have 3 basic processes. Download the SolarStart app, open the SolarStart app, and then access the Wi-Fi points of the inverter, and then continue with the commissioning as described. Good. So in terms of GEN24 Plus compatibility, the GEN24 Plus, its compatibility actually serves as a key element for the implementation of different system solutions, be it thermal storage solution, battery storage solution, and of course, e-mobility. So for storage solution, although these have actually been treated as dedicated webinar topics, including that of the thermal storage and e-mobility, we just decided to pick just a few slides to present for storage solutions, as it's actually one of the most popular solution that is presented with the GEN24 Plus. So why battery storage, one may ask? Well, first of all, it makes it possible for PV surplus energy to be stored. Of course, it boosts self-sufficiency. You can actually use free solar energy to generate usable energy for your appliances. In this case, you have situations where the customer wants to avoid feeding situations, and then we have opportunity of covering your nighttime loads by using the energy stored in your battery, and not just nighttime. You can actually use the energy in the battery during a grid failure. So for storage connection options, first off, we have to note that the GEN24 Plus inverter is a PV inverter, meaning that it uses AC as its control voltage. So once that is recognized, it of course converts the DC to AC as expected, and then of course has the dedicated channel through which, or terminal through which it can charge the battery. And then for the battery options, apart from the BYD battery box premium HVS and HVM, we now also have another compatible battery, which is the LG ResoFlex in power capacity of 8.6 to 7.2 17.2 kilowatts hour. Advantages, there are lots of them, but just to list a few, we have the opportunity of storage of surplus energy, increase of self-consumption, recharging in emergency power, retrofitting for existing inverters is made possible. That is via AC coupling, deep discharge protection, and then of course a high output power is also possible. And then of course, how about the multi-flow technology? Of course, with a hybrid inverter, the GEN24 Plus hybrid inverter, it is possible to have a DC to DC conversion, which is from the module to the battery. That is DC power to DC DC to DC conversion, basically. And then we also have DC to AC, that is converting the DC signal or voltage from the battery to AC to supply the load. We can, of course, also use the DC to AC to actually feed the load, base load, and then, of course, feed into the grid when allowed. And then, of course, it's also possible to take in from the grid and then, of course, charge the battery. And as mentioned earlier, it can also be used for retrofitting purposes. Good. And this is, of course, to back up the statement made that we are actually up there in the top echelons of storage solution and picking up podium positions always during the HTW storage inspection. So let's now quickly look at the various applications where we can have this solution handy. So let's look at a particular scenario where we have the Fronius GEN24 Plus in use without the storage. So this is basically a classic installation of a grid-tied system where we have the hybrid in place. So we'll basically use the PV to douse the effect of consumption from the grid. Next up is application 2, where in this case we have the implementation of storage solution. This will, of course, eventually improve self-consumption ratio and, of course, make it possible for fast amortization. Next up is the possibility with backup power. So this is with the inclusion of an emergency backup power switch, which automatically knocks off the grid line to now enable the kicking in of the full backup function. We also have the third scenario where we have a retrofitting solution with an existing PV inverter, as you can see. And it also comes with an improved version of that retrofitted system, in this case, with a full backup system and with a backup switch implemented. It is also possible to have a fourth scenario where we have a grid-tied system where we make use of surplus energy, not only to charge the battery for later use, we can of course generate hot water for later use also, and then have our EVs sufficiently charged with the most economical means possible. And then there's also, I think, the last scenario for this presentation, where we have the implementation with the backup power switch, of course, knocking off the other solutions once there is a grid failure, as you can see in this case. So for whatever scenario you can think of, we have the Fronius GEN24 Plus there to serve you. Great. So with this, we have come to the end of today's presentation. Just to give you further information, yes, so this particular recording for this particular webinar will be made available on YouTube. And then, of course, you can also find on our YouTube homepage different operating and installation instructions of different devices, inverters out there. These are all available on our YouTube channels. You can also find how-to videos and installation videos and webinar recordings, like I've earlier said. For specificity, you can actually get access to our Sub-Saharan Africa playlist via this link. So with this link, you'll be able to have access to all the webinars we have presented so far, including this one when it is eventually uploaded. So for inquiries for technical training, sales, and after sales, please you can use the information displayed. If you want to have access or contact any of the respective TSAs, please do so according to the TSA for your region, for your particular region. So myself, Cyprian Okolo for the Western Africa region, Byron Kotza for the Southern Africa region, and then of course David Wangi for the Eastern Africa region. So with this, would want to say a very big thank you to all the attendees that have made up time to attend this webinar. We say a very big thank you. And with this, we have come to the end of today's webinar. And until we come your way next time, do have a wonderful rest of the day. Thank you and goodbye.